Hello my friends, welcome to Instant Out Electronic channel. This is Uncle Misha, and today we have an interesting device I got from eBay. So this is definitely ATX power supply related. Let's just take a look what is that. We're gonna use scissors, it's anti-static baggy. Alright, so as you see, we have complete breakdown of ATX power supply. It's like here we are, those two 24-pin, 24-pin support, and this has a shitload of USB thingies. I didn't buy this thing for USB, okay? I bought it just because of this. So my idea is to use this device in a way I would like to test power supplies, all right? Yes, it has this 5 volt, probably DC to DC converter, which actually converts, I assume, 12 volt into 5. Otherwise, I don't understand why would be the converter here if you just need to feed 5 volts right here. So it probably takes 12 volt in and spits out USB right here to power your external devices. But I don't really care. I just care about this and that. So let's take a power supply and see how this thing operates, and I'll explain you my idea. So what my idea is to use this power supply breakdown to connect it to existing power supply. Oh, I think you remember this Corsair HX850 power supply that have issues. So here's the repair attempt video, and I'm trying to get this guy going still, because all right, it already says 5 volt USB. You see what's happening with this guy? It starts, then stops. But actually it shows that power is fine, and I don't understand. The computer, it doesn't start with this power supply. So I just wonder what is going on. All right, so today we're gonna do the following. So we have this breakdown. So 5 volt auxiliary power is on. Hence we have this LED lighting up. So this is 5 volt auxiliary. Maybe I'm mistaken. This is not a voltage regulator. This could be something else, because technically you can just take 5 volts straight off the 5 volt rail. Like, why would you bother? All right, but we have this. This is electronic load, dual channel. So today we're going to do the following. We're going to connect this electronic load, dual channel, to this power supply. Okay, and we're going to load plus 12, plus 5, plus 3, and maybe minus 12. I'm going to see where it's freaking out. All right, guys. So I did a jump cut, and here we are. This is the new cable. This is 20 centimeters, just custom-made cable. I made it from using these things and using this wire I bought in DigiKey. So this is 18 gauge proper copper wire, right, and nicely rated. It's not silicone. This is, I think, this PVC, but it's still pretty good wire. So this is its serial number part number T1306-5-ND. You can buy it on DigiKey and check the properties of the wire. So this guy is supposed to handle 10 amps, I think proper, like 9 amps. So let's try it. I did only one because I made only one because I want to make sure that I'm not going crazy. So this is gonna work. I'm not gonna put a lot of current through this thing, probably like 10 amp max, right? Because 10 amps it's already 120 watts. That's a lot. Alrighty, so let's power our power supply and let's crank it up. So right now it says 12.28 volt. So let's power it on, and it's dropped only 80 millivolts. So now it's 12.2 instead of 12.28 and 24 watts. Okay, let's just go and change current to 5 amps. Okay, we are at 12.10 volt and we're drawing 60 watts. And the wire is barely, like, it's not even warm. Okay, let's make it 10 amps. So now we are at 11.96 volt and the current is 10 amp and it's 120 watts. Well, 119.86. I think it's getting that. No, like skin temperature. 10 amps. So as you see, fan is not spinning, but this thing is actually safely drawing 120 watts of the power supply. So I do not understand yet why we can crank it further. 12 amps, 144 watts. It's just doing it. Oh, I think I can feel it. Let's just dial it back to 5 amps. Alright, so what are you gonna do next? You're gonna MacGyver another one, okay, like this. I can even probably show you my process. It's nothing special. And we're gonna try to load 5 volt and 3 volts simultaneously. You're gonna see, well, 12 and 3, or 12 and 5, maybe 5 and 3, and see what's happening. Well, before I start loading double, I decided to actually load each of those guys individually. Let me try that. So I'm gonna probably shut this guy down. The only thing is, because I use the like a eye socket ones, or I don't know how you call it. Yeah, you have to like, I don't know, maybe I'm gonna cut like opening here just to slide them, because it's sort of annoying to have to unscrew. But let's try 5 volt. Can just split these guys more. I probably could have left this ground right here. I'm gonna just keep it there. Okay, so now let's see what's gonna happen. So now we're gonna load 5 volt rail. So ground from here, 5 volt from here. Let's power it up. We have 5.14 volt. Again, this guy is supposed to handle like shitload of amps at 5 volt. Let's do 5 amp. No, 5 amp right away. Five amps, no problem. Let's do 10 amps. It's a bit dropping more than I wanted to. At 10 amps at 486. Let's make it suffer more. 15 amps at 474, but it's still doing 15 amps. Wire it's decent. Oh, it's getting warm actually. I start feeling the wire. Yeah, well, let's crank it up a little bit more. It's 18 amps. 466 volts. Interesting. Let me take a multimeter. Just maybe this wire it's beyond its capacity. Mm-hmm. 486. Okay, so it's 486. I think it's not so cool because it's just 18 amps. All right, maybe we have to take a look at this 5 volt rail. Okay, let's just stop it. Let it rest. Okay, I will do the same with 3 volt and see how that got. I think I'm not gonna crank it up at that high. Okay, I have reconnected wires to 3.3 volts, and I just read on here on the power supply top, it says 5 volt 45 amps and 3.3 volt 25 amps. I won't be able to push it because this is too dinky wire. I need to have something like 12 gauge, I guess, for this kind of current, which I can do. I have actually 12 gauge, nice silicone wire. Maybe I'll just do it. And because this won't be actually telling, but let's power it up. So right now we have 3.37 volt, and I have already here too many amps. Let me do 10 at least. 10 amps. Let's do it. So at 10 amps it dropped to 311. Let me try 15 amps. 15 amps, 3 volt, 15 amps. It's still 3 volts. I'm curious. Yeah, I'm honestly not sure with the tolerances of voltages, but let me also measure with multimeter here, because obviously oh, 316. I think 316 is fine, but I have to read what are the tolerances. Yeah. Okay, let's power it off. Okay. All right. Let me assemble another wire like this, and we measure few channels in same time simultaneously. Alright, cable is ready, let's try to test it. Okay, we have connected 12 volt and 3.3 volt rails. Let's just power it up. Simultaneously we have 12 and 3.4. Let's just load them same time. Enter. Let's do 5 amp right away for this guy. Switch channel. Let's do 10 amp for 12 volt right away. On. Channel fine on. So now we have 5 amp at one channel and 10 amp, sorry, 5 amp at 3.3 and 10 amp at 12 volt. And seems like it's handling, fan is not turning on, but it's handling that. Yeah, it's already drawing like 140 watts. Sure, I'm not, yeah, 323 at 5 amp, that's not too bad. Let's just crank up some 12 volt even higher. Because usually 12 volt is the 15 amps. Yeah, seems like normal to me. Okay, let's try 5 volts instead of 3 volts. I'm shutting it down just in case. Alrighty. Let's hide this ruler. Alright. Power this guy up. 5 volt and 5.514 and 217. Let's crank right away. 5 volt 10 amps. On. I think 5 volts kind of dropping more than I expected. And enter. 12 volt 10 amps. Enter. On. Let me measure voltages at here. I don't see that. 1198, I think that's pretty good as it can be. And 493. Yeah, it's not a problem. I don't know what the hell is going on, why it doesn't like it. Alright, my friends, so looks like we are actually have to stop here because this is not video about repairing the power supply. This is the video about usefulness of this device. I think for a power supply I can continue on separate video, and electronic load was just added to show you the benefits of breakout. So the main thing that this thing provides is a breakout of voltages right here, which you can use for whatever purpose. Essentially, if you want to turn this power supply and you need like 12 volt, you can do that. Well, you can actually piggyback straight from the connector right here, or just cut some wires here, but I think this is quite useful when it's nicely organized like that. And I think I was wrong about this little chip here. This chip is a latch used to work as a power button latch. So because a regular power button won't work, so you need to, for example, if you want to short the green one and the ground one, the power on, you have to have actually a switch, like to keep it in that position. So this switch, this little chip does, it's like works like a latch. So you engage it and you disengage it. So this is if you want to connect here, that has to be proper latchable button. All right, so I think we're gonna wrap up at this one. So I think I find the usefulness of this device being mostly as a breakdown board. Another thing which I actually would like to do, I just can take this USB connector and just plug it in here and power it up. Yes, and my battery charger, for example, just working. So clearly it provides 5 volt. Well, obviously 5 volt, not 12. Okay. So guys, please don't forget to subscribe if you want to see more videos like that. Like, comment, we'll be happy to hear from you. Stay safe and ciao.